Page 2 of the Chapter 2 sample test. It says graph this piecewise defined function. Don't let all this gibberish confuse you. It says y equals 2x on the interval from negative infinity up to, but not including 1. So, or x is less than 1. So if I go to the graph, make my axis, and I try to draw y equals 2x. If x is 0, 2 times 0 is 0. If x is 1, 2 times 1 is 2. If x is 2, 2 times 2 is 4. Minus 1 would be minus 2, minus 2, minus 4. That would be there. But I only get to draw this for the domain from negative infinity up to, I'm looking at the x's now, the domain, vertical line, up to 1. So I see the line showing up here, and it gets to here, and when I get to 1 it says open circle. So I get to draw this part of the line and nothing else. Now I better put units on here, 2 and 2. Now let's do the second half of this piecewise defined function. It says y equals x plus 1. And this is from 1 to 4. Well, let's draw x plus 1. If x is 0, y would be 1. If x was 1, y would be 2. And if x is 3, we'd get 2 would get 3, 3 would get 4, and it looks like this. Yeah, right there. But I get to only draw it from 1, including, well, that line would go right through there and it would fill in that open circle. So that open circle is gone. Up to 4. 1, 2, 3, 4. That would be to there. And it's a solid because it said equal. And it's a solid because it said equal, and everything in between. So that's a graph of the function. Now it says list intercepts. Well, I'm not doing the parts that I threw away, so I can't count that. It hits the x-axis at 0, 0, and it hits the y-axis at 0, 0, so there's only one intercept, 0, 0. Intercepts are points, so I need to label it like a point. And that's both the x and the y intercept. Now it says find z of 5. This graph is of z. So I go to 5. 1, 2, 3, 4, 5, and I go up, and there's no graph. So z of 5 is undefined. It says find z of 0. If I go to 0, the graph is at 0, so that equals 0. The y value when x is 0 is 0. What's the y value when x is 2? When x is 2, the y value is 3. Now, if you wanted to do these in this, you'd have to say 5. Is it less than 1? Nope. Is 5 between 1 and 4? Nope. Undefined. 0. Is 0 less than 1? Yes. So put 0 in there. 2 times 0 is 0. 2. Is 2 less than 1? Nope. Is it between 1 and 4? Yes. So we'd use this. 2 plus 1 is 3. That's how you do 5. 6. F plus g. F is x squared minus 2x plus g is x plus 1. Simplifying, we combine like terms and we get the negative 2x plus x is negative x. So we have x squared minus x plus 1. And that would be f plus g of x. F times g. So f times g, it's not an open circle, which would be f of g. And so we would multiply these. That would be x squared minus 2x times x plus 1. X squared times x is x to the third. X squared times 1 is plus x squared. Minus 2x times x is minus 2x squared. Minus 2x times 1 is minus 2x. These are like terms because they're both x to the seconds. And I have 1 minus 2 is minus 1. So I have x to the third minus 1x squared minus 2x. F of x plus h. So that's x squared, so it's going to be x, replacing that x with x plus h, it's going to be x plus h squared, but that's not all of f of x. It then says minus 2 times x, but we're replacing the x with x plus h. So that's all of f of x plus h. Then we have minus, and since we got a minus, we have to distribute it, so I really recommend, but I can't get kids to do it, minus what f of x is. Well, that's simply x squared minus 2x over h. Please don't do this without putting the over h. Equals x plus h times x plus h is x squared plus 2xh plus h squared. That's taking x plus h times x plus h and foiling it. I get that. Minus 2 times all of this is minus 2x minus 2h. And then I have to subtract all of this, so that becomes minus x squared minus a minus, so that's plus 2x all over h. The x squareds cancel. The minus 2x and the plus 2x cancel. So I'm left with 2xh plus h squared minus 2h over h. I can factor out an h out of the numerator. It would be then 2x times h is 2xh. H times h is h squared. Then h times negative 2 is negative 2h over h. The h's cancel and I get 2x plus h minus 2. Don't make d hard. It says f divided by g of 2. F with 2 put in it would be 2 squared, because it's x squared, minus 2 times x, which we're putting in 2. So there's f of 2 divided by 2 put into g, and that's just x plus 1, so it's going to be 2 plus 1, replacing the 2 for the x's. And so we get 4 minus 4, 0 over 3, which is 0. 7. We have minus the quantity x minus 1 cubed plus 2. So the parent function is a cube function. So the parent, that's the first thing you should draw. So if I draw it on here, I know that in the parent function, which is y equals x cubed, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. Minus 1 cubed is minus 1. Minus 2 cubed is minus 8. 1, 2, 3, 4, 5, 6, 7, 8. So it comes up here, bends, and then goes on its merry way. 1, 2, 3, 4. So I've got units on the y-axis and on the x-axis, so I know my scale. Now, we've been doing these, and folks have been saying, let's do the inside first. Inside the cube function, there's x minus 1. It's not times the negative 1. It's subtract 1. Inside, there's only that one number. Inside works horizontally, and a subtract 1, it works opposite, so it's going to move horizontally 1. So I take every point that I have here and move it 1 to the right. Even though it looks like minus 1, it goes plus 1. So these 3 points end up there, and the one up here gets moved not above 2, but above 3. The one that was below minus 2 at minus 8 is now going to be at minus 1 minus 8, so it's going to look same shape, but moved right 1. And I better put units on my graph so I don't get docked. Then I work with the outside, and there's 2 of them. There's a negative and a plus 2. The negative is kind of times it, and there's a plus 2. Outside, we do exactly what it says, and we obey order of operations. So the minus is kind of times, so that would happen first. Now, outside we were working vertically. So a minus times the parent function, flips it vertically. Top goes to bottom, bottom goes to the top. So I take the same graph, and every point that's below the x-axis goes above. And if it's on, it stays there. If it's above, it goes below. And so this one that was above by 8 goes down below by 8. And the one that was below by 8 goes above by 8. And it looks like putting units on. And so it was a reflection over x-axis. And then we got to do the plus 2. It's on the outside, so it works vertically. It does it like it looks like it should, so plus 2 would move it all up 2, and so finally I would draw this curve up 2. So the one that was at 0 will go up 2, the one that was at plus 1 will go to 3, the one that was a minus 1 will go to plus 1, the one that was down here at 8 will go down to 6, which is right there, and the other one will be way up there, and it'll look like that. And putting units on, and it's up 2. So I've described it, and I've drawn each step in the right order and identified the parent function. That's page 2.